Okay, today we're going to talk about greatest common factor, or GCF. First thing we need to realize is, what does factor mean?
Well, factor means all of the numbers that can be multiplied together to make another number. So, for example, let's look at 18.
All right, so factors of 18, we start with 1 and 18.
All right, 2 times 9 and 3 times 6. Now, 4 and 5 are not factors, so that means we've actually met in the middle. So these are all of our factors of 18.
All right, let's look at another number. How about 24?
Okay, so we always begin with 1 and end with that number. So 1 times 24 equals 24.
Okay. 2 times 12.
3 times 8.
4 times 6.
All right, and the only number left is 5, and 5 is not a factor. So therefore, we've met in the middle, and these are all the factors. Now, when it says greatest common factor, it means that we're looking for the numbers that they have in common.
All right, so we have 1, 2, 3, and 6.
Okay, and again, greatest common factor means we want the largest number that, or the largest factor that they both have in common. So what's the largest number they have in common?
That's going to be 6.
So the greatest common factor of 18 and 24 is 6. All right, now what do we use greatest common factor for?
Well, I can use factors to help me simplify fractions.
Okay, so let's look at simplifying fractions. For example, we have 28 and 49. So let's find the greatest common factor of 28 and 49.
All right, 28, 49. Start with 1 in that number, so 1 and 28.
So 2 times 14.
3 does not go into 28.
4 times 7. All right, 5 doesn't go into it.
And neither does 6, so
Okay.
we're done.
So we've met in the middle, so those are all the factors. All right, how about 49?
Okay, 1 and 49.
All right, 2 doesn't go into it because it's not even. 3 doesn't go into it because 9 plus 4 is 13, and 3 doesn't go into 13.
4 doesn't go into it.
5 doesn't go into it. 6 doesn't go into it. What about 7?
7 times 7 is 49.
All right, so now we've definitely met in the middle there because we have the same number on both sides. So what are the common factors that we have?
That would just be 1 and 7.
Okay, so what is the largest factor that these two numbers have in common?
7.
Excellent. So the greatest common factor of 28 and 49 is 7. And what we can do with that is we now know that we can divide both of these numbers by 7 to help us simplify.
That gives me 4 over 7.
Excellent. So, and the nice thing about simplifying using greatest common factor is you know that it cannot be simplified any more than this.
All right.
Excellent.
What about real world stuff like word problems?
Okay, so let's look at a real world situation.
Okay, Ginny's making bracelets for some of her friends. She has 18 yellow beads and 30 blue beads. If each bracelet has the same combination of beads, what's the largest number of bracelets she can make? Well, let's look at important stuff first. 18 yellow beads, that's important. And 30 blue beads, that's going to be important as well.
Okay.
We also, other important things would be the same combination, and that we're looking for the largest number.
Okay, why is same combination important?
Same combination is important because that's going to tell us we need to use the same number of beads in each one. And then largest number means that it's going to be greatest common factor.
Okay, so let's look at the greatest common factor of 18 and 30.
All right, 18, we've got 1 and 18.
All right, 2 times 9.
And 3 times 6.
All right, and 4 and 5 aren't factors, so that means those are all of our factors. Okay, let's look at 30. 1 and 30.
2 and 15.
3 and 10. 4 isn't a factor, but 5 is.
5 times 6.
Okay, and we've met in the middle, so we know that that's all of our factors. So which factors do they have in common?
That would be 1, 2, 3, and 6.
All right, and what is the largest number or the greatest common factor?
6.
So the GCF for 18 and 30 is 6. Now, how does that help us solve our word problem?
And that means that using the same number of beads in each bracelet, she can make 6 bracelets.
All right, so my answer is she can make 6 bracelets. All right, thank you guys.